Hi guys, this is number 17 on 11.5 homework. There are 3 parts, so I'm going to do all 3 of them on here. I use gray to highlight the shaded area so that you are able to see it, but still see my work. So the first problem is a square, and inside of it is an equilateral triangle. The shaded region is made up of subtracting the triangle from the square. So first, let's find the area of the square. We know if the side is 6, my side squared is going to be 36. So the shaded area will be 36 minus, now we need to find the area of the equilateral triangle. And remember, you can use the formula for an equilateral triangle here. So my side squared would be 36, radical 3 over 4. However, we can simplify that, so the area of the shaded region will end up being 36 minus 9 radical 3. Moving on to B. We have a hexagon, and inside of it, we have a square. Now again, we are trying to find the shaded area. So the shaded region is going to be made up from finding the area of the hexagon and subtracting that from the triangle. Now, another way you could look at it is that we have 3 triangles here. The gray shaded area makes up 3 triangles, so I'm going to use that to find the area. The first thing we need to know, because we're dealing with regular polygons, every inside angle is going to be congruent. So this will be congruent, these angles will be congruent, and so forth. What we are able to do is use my formula, 180 times a quantity of n minus 2 all over n. That gives me the inside angle. The reason why that helps me is because these angles are all going to be 120 degrees. Now, one thing you can notice is if I drop an altitude, I have a right angle. Instead of it being 120, we are going to be left with 60 degrees inside my angle. And now, as you can see, we're dealing with a 30, 60, 90 right triangle. So across from my right angle is going to be 6, that's 2x. So across from my 30-degree angle will just be 3, and across from my 60-degree angle will be 3 radical 3. Now, one thing you'll notice, that's only half of the side length. I need to double the entire side length. So I will find that my side length of the triangle is going to be 6 radical 3. Okay, now remember, we can find half the base times the height. Okay, so half the base of my triangle we just found is 6 radical 3 times the height of my triangle, which is 3. Now, what you would notice is this only finds the area of one shaded triangle. There are 3 shaded triangles. So again, I'm going to multiply by 3. That way I can find the area of the entire shaded region. That is going to give me 27 radical 3. That is the area of the shaded. Moving on to part C. Again, we have an a regular hexagon, and then the shaded area is made up from a rectangle. Again, what we can notice is that if the hexagon is regular, each side is going to also be 6. Each angle, inside angle, is going to be 120 degrees as well. So what we can do, again, is drop our altitude of the triangle. The reason why this is helpful is now, again, we have a 30, 60, 90. This becomes 90. Instead of 120, we just bisect that angle. That's going to be 60. And then we have 30. Again, across from my right angle is 6, that's 2x. So across from my 30-degree angle would be x, which is 3, and across from 60 is 3 radical 3. Now that's only half the side length. The entire side length is multiplied by 2. So we're going to end up with 6 radical 2. So the area of that rectangle is going to be the base, which is 6, times the height, which we just found as 6 radical 2. So the area will be 36 radical 2. I hope this helps.